So today is the solid state physics lecture 2. This is the crystallography lecture. Okay, so there are two main terms, lattice and basis. The lattice is the periodic arrangement of imaginary points in the space. You can see here, these are the arrangement. We can take it like this is a rhombus and this is periodic. This arrangement is periodic along this x-axis and y-axis. If it is 2D, then the lattice is 2D and the crystal will also be 2D. And if it will be 3D, then there will be another axis along the z-axis which is perpendicular to the x and y-axis. So, if you want to consider the 3D crystal, then we have to assume the 3D lattice. Okay, so these dots are lattice points which are periodical in the both directions. Now these are just the points. There is no atom or nothing there. These are just points. Now these black spheres, these are the atoms, or it can be the group of atoms also. So when we put these atoms in the arrangement, means these atoms are called bases. When we are putting bases or we are attaching the bases to the lattice or to each lattice point, the crystal structure is formed. So the basis and the lattice is making the crystal structure. Now the basis can be different types, like monoatomic basis means when we are putting one atom in each lattice point. Diatomic basis means we are putting two atoms in each lattice point, and then 3 to any other number. These are called polyatomic bases. Now a lattice will be Bravais lattice or the space lattice if each lattice point has identical surroundings. Means if we consider this lattice point, so it has here one atom, this side, this side, and this side. There are all 6 sides. Now if we consider this atom, it has also the similar surroundings. So if the surroundings are same, identical, then it will be called as Bravais lattice. If every lattice point has identical surroundings, only then it is called Bravais lattice. And all this crystal structure we will study, every crystal structure, the lattice is the Bravais lattice. An ideal crystal or an ideal lattice, there is no end, means no finite boundary. Ideal lattice has infinite boundary. If a crystal has finite boundary, then it is a defect. So it is a defect in the crystal structure. So the crystal structure which has finite boundary will be called non-ideal. So it means there is no ideal crystal. Okay. Now there is an important term called unit cell. Unit cell is the smallest unit of lattice. Okay, unit cells are of two kinds. First one is primitive, and then this can be non-primitive. Primitive means primitive unit cell has effective number of lattice point is 1. If the unit cell is primitive, it has only one lattice point. If non-primitive means it can have more than one lattice point. So number of atoms in one primitive cell is equal to the number of atoms in basis. Okay, now there is another term which is called lattice parameter or lattice constant, which is basically the side of the unit cell, side of the unit cell, and it can be presented by small a. There can be lattice factors. So this ABC should have an arrow on its head, but I did not find the arrow, so just for your understanding, when you will write it in your notebook, please put an arrow above A, B, and C. So these are the lattice factors. Lattice factors means when we take the magnitude of this A vector, we will get the corresponding lattice parameter on the direction. Means if A is the lattice vector along x-axis, B is the lattice vector along y-axis, and C is the lattice vector along z-axis, then the magnitude of A will give the unit cell, the side of the unit cell along x-axis. And if it is a square lattice, then the angle between A and B vector will be 90 degree, and the magnitude of A and B will be equal, and the magnitude of C will be 0 in case of a square lattice. Okay, this is for today's lecture. Next step, I will discuss the types of lattices and crystal system in 2D and 3D. So next lecture will be very important. Like I will discuss every lattice, like square, rectangular, hexagonal, oblique, and also the 14 Bravais lattices. So everything I will discuss in the next class.